Okay, so here we have two parallel wires whose centers are 15 centimeters apart, carry equal currents in opposite direction. Find the inductance of 80 centimeter length of such a pair of wires. The radius of each of the wires is 0.1 centimeter. Okay, so we have to find inductance, right? If you don't want to be bothered, finding the ready formula, then of course you can use this formula where we have particular is already derived, where L is equal mu naught current divided by pi, then ln d minus r over r. I'm quite sure most of you, I think you was using just ready formula, but however, if you want to understand how we can come to this formula, then just bear with me. Now, first of all, we have to find the magnetic flux, okay, through this very small area in between them, let's say, like located anywhere, okay? Let's say just it's located not in the center, but somewhere here. Okay, so say that this is this length, I would say dx, and this is the length of L, okay? Before moving on, I think we have to clarify a few formulas that we're going to use it. So basically we have formula where the flux is equal L times I, right? Then we have to find here L, which is flux divided by current, right? The current is not given, so that means we have to somehow get rid of it. Flux is also not given, but we have to find the flux here. Okay, so let's say it's very small area, the length is dx, the height is L. If you want to find the flux of this small thing, it gives you I would say a df, okay, very small flux. Now, how can we find it? The first of all, the distance from here, from the center of the wire up to here will be what? Let's say it will be x, okay, x. Then what about the second wire? So this is the first wire, this is the second wire. What about the second wire? The second wire will be what? The second wire will be the distance of that one should give you d minus x, right? So if you add this x plus d minus x, you will get basically the distance, correct? Okay, now we know that magnetic flux is equal by the general formula, right? B times area, correct? But since here we have very small area, then we can say that we have to find the very small flux. So d flux is equal B times dA, right? Then what about the B? What about the B of the wire 1? B of the wire 1, it will be the mu naught current divided by 2 pi x, right? Then what about the B2? B2 is equal mu naught current divided by 2 pi, and that distance is what? That distance is d minus x, correct? Now, we know that current are pointing opposite, so therefore the total magnetic field will be, you just have to add this to magnetic field. So that means we can say that the flux of the small area is equal to the total field will be mu naught current divided 2 pi x, okay, plus mu naught current divided by 2 pi d minus x, right? And then this d area is equal to what? So this area of small thing is dA, which is equal dx times L, right? So I would say it's just the L times dx, okay? Then if you want to find total flux between these two wires, okay, total flux between these two wires, then what you have to do, you have to just integrate both sides, okay? So that means when you integrate the flux, you will get total flux and equal to the let's took the constants and put it outside of the integration, okay? So we have mu naught, which is a constant, current is constant, L is constant, divided 2 pi is constant. Then the integral 1 over x plus 1 over d minus x, okay, and dx. Now what are the limits now here? What are the limits? If you want to find this distance, okay, that distance, then what you have to put? You have to put when x is equal to r, then this one will be what? This one will be d minus x, right? So d minus r, because if you sum them, you will get this, you know, that distance. I would say let's call it is a b, okay, b distance, which is between these two wires. Okay, so that means I have to put here r. That one is d minus r, okay. Then what will happen? Then after that, we can see that flux is equal mu naught current L divided by 2 pi. That one will be ln x plus ln d minus x, and the limits will be r d minus r, correct? Okay, so I will just skip this few steps and I will write it down that the flux finally will be equal to the mu naught current L divided by pi ln d minus r divided by r, okay. Now since we said that the flux is equal to the L times I, so L is equal flux divided by I. So that means it will give us the L, which is equal to the mu naught L divided by pi ln d minus r over r. So I guess that's it. If you plug the numbers, you should get the answer.